This is SpaceTime, Series 28, Episode 142, for broadcast on the 3rd of December 2025. Coming up on SpaceTime, a new study has found that the small planet that collided with the Earth to create our moon also originated from the inner solar system. An update on Lucy's mission to Jupiter's Trojan asteroids. And NASA rules that Starliner's next mission to the International Space Station will be limited to cargo only. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has found that the small planet that collided with the Earth to create our moon also originated from the inner solar system. About 4.5 billion years ago, the most momentous event in the history of our planet occurred. A huge celestial body about the size of the planet Mars, which astronomers have now named Theia, collided with a young proto-Earth, creating a vast magma ocean which eventually coalesced, differentiated, and then solidified to form the Earth as we know it today. Meanwhile, some of the debris ejected from that impact was flung up into orbit, eventually coalescing to form the Moon. Exactly how that collision unfolded and what precisely happened afterwards has not been conclusively clarified. What is certain, however, is that the size, composition and orbit of the Earth changed as a result, and that the impact marked the birth of our constant companion in space, the Moon. But there are lots of questions yet to be answered. What kind of body was this Theia that so dramatically altered the course of our planet's development? How big was Theia really? We think it was about a third the size of the Earth. What was it made of? And from which part of the solar system did it come crashing into the Earth? The problem is, finding answers to these questions is difficult. After all, Theia was completely destroyed in that collision. Nevertheless, faint traces of it can still be found today in the composition of the Earth and Moon. Now, a report in the journal Science by researchers at the Max Planck Institute and the University of Chicago have worked out a possible list of ingredients that may have made up Theia, and thus helps to point us in the direction of its place of origin. You see, the ratio of certain metal isotopes present in a body can be especially revealing. Isotopes are variants of the same element that differ only in the number of neutrons in their atomic nucleus, and thus in their mass. In the early solar system, the isotopes of certain given elements were unlikely to be evenly distributed. At the outer edge of the solar system, for example, isotopes occurred in a slightly different ratio than what they did near the Sun. So information about the origin of a body's original building blocks is thus stored in its isotopic composition. To reach their conclusions in this study, the authors determined the ratio of different iron isotopes in Earth and Moon rocks with unprecedented precision. They examined 15 terrestrial rocks and 6 lunar rock samples which were brought back by the Apollo missions. Earlier measurements of the isotope ratios of chromium, calcium, titanium and zirconium had already shown that the Earth and Moon are indistinguishable in terms of their composition, so that clearly doesn't allow for any direct conclusions about Theia. There are simply too many possible collision scenarios. Now, most models assume that the Moon was formed almost exclusively from ejected material which was flung off from Theia. But it's also possible that it consists primarily of material from the early Earth's mantle, or that the rocks from the Earth and Theia were mixed together. Now, in order to learn more about Theia, the authors applied a kind of reverse engineering for planets. Based on the matching isotope ratios in today's terrestrial lunar rocks, they looked at which compositions and sizes of Theia and which composition of the early Earth could have led to the two bodies' current compositions. In their investigations, the authors looked not only at iron isotopes, but also at those of chromium, molybdenum and zirconium. The different elements give access to different phases of planetary formation. Long before the devastating encounter with Theia, a kind of sorting process had already taken place inside the early Earth, with the formation of the planet's iron core. Some elements, such as iron and molybdenum, accumulated there. So afterwards they were largely absent from the rocky mantle above. The iron found in Earth's mantle today could therefore only have arrived after the core had formed. It may have come from Theia. Other elements, such as zirconium, which didn't sink to the core, document the entire history of our planet's formation. Of the mathematically possible compositions of Theia and the early Earth that result from the calculations, some can be ruled out as implausible. While the composition of the early Earth can be represented predominantly as a mixture of known meteorite classes, this isn't the case with Theia. Different meteorite classes originate from different areas of the outer solar system. They therefore serve as references for the building material that was available during the formation of both the early Earth and Theia. In the case of Theia, however, previously unknown material may also have been involved. And the authors believe that this material's origin lies closer to the Sun than the orbit of the Earth. The calculations, therefore, suggest that Theia itself must have originated closer to the Sun than Earth's orbit. This is SpaceTime. Still to come, an update on Lucy's mission to Jupiter's Trojan asteroids, and NASA rules that the trouble-plagued Starliner's next mission to the International Space Station will be limited to cargo only. All that and more still to come on SpaceTime. One of the many exciting missions currently underway is NASA's Lucy spacecraft, which is on its way to study Jupiter's Trojan asteroids. Lucy was launched back in October 2021. It's on a 12-year mission to study the Trojans, two clusters of asteroids that share the gas giant's orbit around the Sun. Trojans are families of asteroids kept in gravitationally stable bound groups at the Lagrangian L4 and L5 positions, located 60 degrees ahead and 60 degrees behind Jupiter's orbit around the Sun. Lagrangian points are named in honour of the Italian-French mathematician Giuseppe Louis Lagrange, who was working on the general three-body problem in orbital mechanics. Lagrangian points are places in space where the gravitational pull of two bodies, such as in this case between the Sun and Jupiter, tend to cancel each other out, thereby allowing smaller objects such as asteroids or spacecraft to remain there for extended periods of time. There are 5 Lagrangian points, known as L1, 2, 3, 4 and 5. Now L1, 2 and 3 are all along a line connecting the two bodies. Let's say it's the Earth and the Sun. In that case, L1 is between the Earth and the Sun, and is often used by spacecraft needing an uninterrupted view of the Sun, such as the Solar and Heliospheric Observatory satellite SOHO. The L2 position is on the opposite side of the Earth to the Sun. It's home to spacecraft like the Webb Space Telescope because it's ideal for astronomy as spacecraft are still close enough to communicate with the Earth and can keep the Sun, Earth and Moon behind them, allowing them to gain solar power while still providing a clear, dark view of deep space for their telescopes. The L3 position is on the opposite side of the Sun to where the Earth is. Because L3 is always hidden from the Earth by the Sun, it's become popular in science fiction as the location for any hypothetical second Earths. But it's the L4 and L5 positions which provide stable orbits around 60 degrees in front of and 60 degrees behind Earth's orbit around the Sun. And it's at these locations where Trojan asteroids, such as those orbiting with Jupiter, are commonly found. Jupiter's Trojans are distributed into 2 elongated curved regions around these Lagrangian points, with an average semicircular axis of around 5.2 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, 150 million kilometres or 8.3 light minutes. The first Jovian Trojan discovered, 588 Achilles, was spotted in 1906 by German astronomer Max Wolf. So far, more than 15,300 Jovian Trojans have been detected. Now, by convention, they're each named from Greek mythology, after a figure of the Trojan Wars, hence the name Trojan. It later became convention to name Jupiter's L4 Trojan asteroids after Greek characters and the L5 asteroids after Trojan characters. Astronomers estimate there are more than 1 million Jovian Trojans larger than a kilometre in size. Now, that's about the same as the number of asteroids larger than a kilometre in the main asteroid belt between Mars and Jupiter. Many Jovian Trojans appear to be dark bodies with reddish, featureless spectra. No firm evidence of the presence of water or any other specific compound on their surfaces has ever been obtained, but it is thought that they're coated in tholins, organic polymers formed by the Sun's radiation. The Jovian Trojans are thought to have been captured into their orbits during the early stages of the solar system's formation, or at the most slightly later during the late heavy bombardment, during the migration of the giant planets. Mind you, Jupiter isn't alone to have Trojan asteroids. They've been found orbiting many of the other planets in our solar system as well, including Mars, Neptune, Uranus, and even the Earth. No spacecraft has ever visited a Jovian Trojan. And that's where the Lucy mission comes in. Lucy is covering some 6.5 billion kilometres, visiting a record-breaking 7 asteroids, 1 in the main asteroid belt and 6 Trojans. The mission's principal investigator, Harold Leveson from the Southwest Research Institute in Boulder, Colorado, says Trojans are leftovers from the early days of our solar system. Effectively, they're fossils of planetary formation, and therefore hold vital clues about deciphering the solar system's early history. He says, like Lucy, the human ancestor fossil after which it's named, the Lucy spacecraft will revolutionize science's understanding of the solar system's origins. The mission will provide an unparalleled glimpse of the formation of the solar system, helping astronomers better understand the source of volatiles and organics on terrestrial planets, as well as the evolution of the planetary system as a whole. This report from NASA TV.
We are going to an amazing variety of objects with this mission.
The Lucy mission is going to fly past 7 asteroids in 12 years with 1 spacecraft.
And it's really almost pure luck that allowed us to get as many rich targets as we are. Literally, the planets were aligning to allow us to do this mission.
The Lucy mission is named after the Lucy fossil, the Australopithecus fossil that was discovered in the 1970s in Ethiopia. And just like the Lucy fossil transformed our understanding of hominid evolution, the Lucy mission will transform our understanding of solar system evolution.
Trojan asteroids are an interesting population of small bodies that are left over from the formation of the planets, and they lead or follow Jupiter in its orbit by roughly 60 degrees. If you just look at the gravitational attraction of the Sun and Jupiter and put something exactly 60 degrees in front of Jupiter, it's stable forever. So as a result, these objects are really the leftovers of planet formation. The stuff that went into growing Jupiter and Saturn are now trapped in these locations.
The very first asteroid we get to is a main belt asteroid named Donald Johanson. We named that asteroid in honor of the researcher who found the Lucy fossil. We'll use that asteroid to do a rehearsal on our spacecraft to make sure everything is working properly so that when we get to the Trojan asteroids, we're ready to go.
We're visiting both of the Trojan swarms. In the first orbit, we're going into the leading swarm, and we're going to encounter 4 Trojan targets.
Eurybates, Ptolemy, Lucas, and Oris. And from this, we're going to sample the diversity in sizes and colors and compositions. The first 2 flybys happen just about 30 days apart, so it's going to be a pretty busy kickoff to the season of exploring the asteroids in the L4 swarm. And then we'll fly past Earth again and out to the L5 swarm.
The final object we're visiting, which I must admit is my favorite, is a binary object.
So that's 2 Trojans that orbit a common center of mass. It's called Patroclus and Menecius.
These objects are nearly identical in size that orbit one another.
From the Lucy mission, we're going to study the diversity of our targets because that tells us something about their origin and where they came from.
The interesting thing about small bodies in general is they are the leftovers of planet formation. If you look at the 8 planets that we know about, for example, they are highly processed because of internal processing. These asteroids are objects that really haven't changed much from when the planets assembled themselves. And as a result, by studying them, we can figure out the physical conditions of the early solar system as well as how the planets grew and how they moved around early on.
All of that will help us form a detailed picture of what these objects really look like. Because right now, our best images are just a point of light. Even using the Hubble Space Telescope or adaptive optics on large ground-based telescopes, we can't see surface details. And it's going to take the Lucy mission to go to these targets and see what they're really made of and what they look like.
And in that report from NASA TV, we heard from Lucy Principal Investigator Hal Leveson and Lucy Deputy Principal Investigator Kathy Olkin, both from the Southwest Research Institute in Boulder, Colorado. This is SpaceTime. Still to come, NASA says Boeing's trouble-plagued Starliner spacecraft won't be carrying any astronauts on its next flight to the International Space Station. And later in the science report, neurologists have identified the 5 major epochs of brain structure over the course of a human lifetime. All that and more still to come on SpaceTime. NASA says Boeing's trouble-plagued Starliner spacecraft won't be carrying any astronauts on its next flight to the International Space Station. Instead, the mission will be limited to cargo and supplies only. The decision comes 8 months after the first and only manned Starliner flight saw the capsule return to Earth empty, with its crew left stranded on the International Space Station for more than 9 months. That followed a series of issues with the vehicle's propulsion and orbital maneuvering systems, as well as its helium pressurization system. And it's not the first time Starliner suffered issues. Faulty computer programming prevented the first Starliner mission to the space station from even reaching its target. And more faulty computer programming, which luckily was corrected in time, would have caused the Starliner to be destroyed during its re-entry. There have been other problems with corrosion in the spacecraft's propulsion system as well, issues with the strength of the parachute webbing, the concerns over the safety of insulation on the spacecraft's wiring harness, and problems with environmental controls inside the spacecraft's cabin. For Starliner, it's been a case of one problem after another, and it seems NASA's had enough. As well as limiting its next flight to cargo only, NASA's also slashed the total number of Starliner missions down from 6 to 4. As for Starliner's next flight, that's the cargo mission, it's currently slated for April next year. If that goes well, then a manned mission could happen towards the end of the year. The remaining 2 flights will also carry crew to the International Space Station until the orbiting outpost is decommissioned in 2030. Starliner was one of 2 spacecraft selected by NASA back in 2014 as part of the agency's Commercial Crew Program to transport astronauts to and from the space station. But unlike the other successful applicant, SpaceX's Dragon spacecraft, which has performed flawlessly, Boeing's Starliner has suffered from continuous failures and quality control blunders. It's been a costly disaster for Boeing. SpaceX launched its first manned Dragon mission to the space station for NASA in 2020. And it's now completed 12 crew change missions, as well as several private missions into orbit. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Neuroscientists have identified 5 major epochs of brain structure over the course of a human lifetime. The findings, reported in the journal Nature Communications, show how human brains rewire themselves to support different ways of thinking as people grow, mature, and ultimately decline. The study, led by Cambridge University, compared the brains of 3,802 people between 0 and 90 years of age using MRI scans, which map neural connections by tracking how water molecules move through brain tissue. They found the brain structure for an average human life is split up into 4 pivotal turning points between birth and death. It seems childhood brain topology runs from birth until a turning point at around age 9. That's when it transitions to an adolescent phase. That's an era that lasts up until the age of around 32 on average. The brain's neural wiring then shifts into a more adult mode. This is the longest era, which can last over 3 decades. A third turning point, around the age of 66, marks the start of an early aging phase of brain architecture. And finally, the late aging brain takes shape around the age of 83 years old. So, what's going on inside the noggin? Well, during the early childhood phase, the brain undergoes network consolidation as a wealth of synapses, that's the connections between neurons, overproduced in a baby's brain, are whittled down, with only the more active ones surviving. Across the whole human brain, connections rewire in the same pattern from birth until about 9 years of age. Meanwhile, grey and white matter grow rapidly in volume, so that cortical thickness, that's the distance between the outer grey matter and the inner white matter, reaches a peak, and cortical folding, that's the characteristic ridges on the outer brain, stabilizes. By the first turning point, at around the age of 9, the brain is experiencing a step change in cognitive capacity, as well as an increased risk of mental health disorders. The second epoch of the brain, that's the adolescent era, sees white matter continue to grow in volume, so organisation of the brain's communications network is increasingly refined as measured by the diffusion of water in the scans. This era is defined by the efficiency of connections, both within specific regions as well as rapid communication right across the whole brain, which is related to enhanced cognitive performance. Neural efficiency is well connected by short pathways, and the adolescent era is the only one in which this efficiency is increasing. The authors say these developments of the brain peak in the early 30s, which is the strongest topological turning point for the entire lifespan. At age 32, the longest era, that of adulthood, begins. Brain architecture stabilizes compared to previous phases, with no major turning points for 30 years, and corresponds with a plateau in intelligence and personality. They also found segregation is more noticeable during this epoch, as different regions of the brain slowly start to become more compartmentalized. The turning point at age 66 sees reduced connectivity, as white matter starts to degenerate. The last turning point comes around the age of 83, when the brain structure shifts from global to local regions, as neural connectivity declines. A long-term study has shown that water fluoridation doesn't have any negative effects on brain development. In fact, the findings, reported in the journal Science Advances, actually found a slight boost in cognition in children. Previous studies looked at exposure to very high levels of fluoride far beyond recommended standards, so the authors of this new research wanted to study levels representative of what one would usually find in their tap water. They looked at language and math test results from around 58,000 United States high school kids in 1980, and the water fluoridation levels they would have experienced since conception. After accounting for other factors, they found kids continuously exposed to at least 0.7 milligrams per litre of water fluoride had better test results, followed by those exposed to similar levels for just part of their childhood. China's People Liberation Army has reported the successful test of a new type of non-nuclear hydrogen bomb. A report in the Chinese language journal of projectiles, rockets, missiles and guidance claims the new weapon generates a white-hot fireball that can last 15 times longer than a TNT blast. The 2-kilogram device uses magnesium hydride, a magnesium-based solid-state hydrogen material which generated a fireball of over 1,000 degrees Celsius. This material stores considerably more hydrogen than a pressurized tank and was originally developed to bring the gas to off-grid areas where it could then be used to power fuel cells for clean electricity and heat. When activated by conventional explosives, the magnesium hydride bomb underwent rapid thermal decomposition, releasing hydrogen gas that ignited into a sustained, rapidly spreading inferno. The chain reaction begins when detonation shock waves fracture magnesium hydride into micron-scale particles, exposing fresh surfaces. Under constrained detonation, peak overpressure reached 428.43 kilopascals at 2 meters, about 40% that of TNT's blast force, but with a far greater heat projection range. Well, the doomsday countdown to digital ID is now on. This time next week, Australia's controversial new social media bans for children under the age of 16 will come into effect. The world-first legislation is being marketed as a way to protect kids from bullying. But it doesn't stop kids using left-wing social media platforms like Blue Sky, or for that matter, chat rooms in many of the most popular computer games. In reality, it's a thinly disguised Trojan horse designed to force all Australian adults to adopt a digital ID as if they want to retain access to their own social media accounts. It's a way around the public's objection to the defeated Australia Card ID scheme of the 1980s, which was overwhelmingly rejected by the people. So why the fear-mongering? Well, digital ID will allow faceless bureaucrats, security organisations and politicians to develop a Big Brother-style digital link connecting everything, monitoring everything you do, where you go, what you look at, and even what you say, in the process providing fact-based insights into what you're thinking. Then there's the issue of security and how easily your digital ID and all it contains about you can be hacked. Your digital ID will be the Australian answer to Beijing's social credit scheme, where those not considered worthy by China's Communist Party face restrictions in where they can live, where they can go, what they have access to, how they can travel, and where their children can go to school. Australians saw the first hints of what's to come during the COVID pandemic, when voluntary digital ID schemes were repeatedly used by police to track people's movements. Technology editor Alex Zaharov-Reutt from TechAdvice.life says in simple terms, this new digital ID scheme will be a key step in the erosion of people's rights. It's only one small slice, but step by step, those rights will disappear. And it all starts next week.
Look, there seems to be this concerted effort globally to want to set up digital ID. And this clearly is something that will remove anonymity from the internet. Everything you do will be tracked. And it's all being done under the guise of won't somebody protect the children. And, Roblox, for example, has algorithms. You've got to take a photo of your face and they're looking at the various things you've been doing in the system. But ultimately, we're relying upon algorithms to figure these things out. And the only real way of doing it is to get some sort of an ID from a parent, from, a passport, something to prove that you are of a certain age. But again, this is going to remove anonymity from the internet, and everything that you will do will be tracked. And so there is a movement now to not comply with digital ID. But this is happening globally around the world. Governments are all coming together to put these social media bans in place. Malaysia's doing it. The UK wants digital ID. And I don't know if VPNs are going to be enough. There needs to be a pushback from the public to say no. And even in Australia, we have a couple of young kids who are taking the government to the High Court to have the digital ID system blocked. So this seems to be a watershed moment in the modern civilization.
Is this really part of a surreptitious effort by governments to just gain control over everything you have access to, all the information you get?
Well, it certainly seems that way. I mean, everything that the governments have been trying to do, even in Australia, we had conservative and socialist governments, and they tried all sorts of firewalls and they tried various things to try and control people.
Yeah, we had the attempt of an Australia card years ago, and the citizenry resoundingly said no to that, but it doesn't stop the bureaucrats or the politicians from wanting to implement that. We had a situation where we had special ID for COVID. Well, that simply gave the police a chance to track everyone's movements.
Yeah, papers, please, as we saw in Nazi Germany. Look, the problem is that the unelected deep state globally wants control. They want to stay in power. They want to do the things they have been accused of doing and maintain power and debase the currency and do all these things that some claim are conspiracies. But it's clear that if you can maintain your position of power and you can worm your way through the system, why wouldn't you do it? And we've seen that time and again throughout history. And in the 21st century, with all of the digital technologies now at the disposal of big tech, but also government, well, we're seeing them work together and trying to hold people down. I mean, thank goodness for the United States and their First Amendment. But the deep state is fighting back. And it's up to us as citizens, global citizens, to say, no, we don't want unelected people to usurp our privacy.
We're sort of seeing human rights disappear one by one, and it's not that they're being taken from us. The citizenry are gladly giving them up, it seems, for an easier life.
Benjamin Franklin said that if you give up a little liberty for a little security, then you deserve neither. And this is where people abdicating their responsibilities as human beings to Big Brother is the fast track to dystopia. I mean, that's why we had Animal Farm. That's why we had 1984 from George Orwell. That's why we've had so many movies and TV shows about dystopia, because people are worried. I mean, these are warnings to ourselves to not let this sort of thing happen to us. We live at a time where, as Ronald Reagan said, freedom and liberty is not passed down through the bloodline, but must be fought for and protected by every generation. And we stand at the point at which the future generations of this planet could be living under dystopia. Let's hope that that doesn't happen.
That's Alex Zaharov-Reutt from TechAdvice.life. And just in case you think advanced algorithms will circumvent all the problems of digital IDs, think again. Remember, these are the same sophisticated algorithms which keep flagging our SpaceTime posts displaying astronomical images of exoplanets as possible pornography. I mean, granted it is space porn, but that's not what the algorithms are thinking. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.